Hi, I'm Paul, and today we're going to learn how to design this mechanism, but now in SolidWorks. So we have the mechanism built in GeoGebra. So what we have to do, first of all, is take a screenshot of the mechanism and go to an image editor, for instance, Paint, copy it, and save the image. So now what we have to do is go to SolidWorks and start a new part. So once we're here, we're gonna create a sketch into the front plane. So we are gonna open the sketch, and we are gonna import the image we want to use. So to do it, what you have to do is go to Tools, then Sketch Tools, Sketch Picture, and we can import the picture that we have created. So we open it, and you can see that it has been imported here. Okay, so now we press OK, and what we will do is put a point in each point that we will be interested in. So for instance, this point here, this point here, this point here, and the rest of them. Okay, perfect. So now we have all the points that we're interested into. We can see them marked in these blue markers. So what we're going to do now is measure the distance. Sorry, adapt the distance to the dimensions that we want. So we want to work in inches, and then we're going to open the sketch again because we are not finished, and we're going to pick the smart dimension. I'm going to say, okay, so from here to here, I want this to be 8 inches, for instance. You will see that now all the points that we chose will shrink a little. So the image will move with respect to the points. That's because when you first put the points, the SolidWorks work with the distances that they want. But once you introduce the first distance, then everybody gets either shrinked or expanded, depending on when you choose. So for instance, if you choose 8 inches, you can choose whatever you want. But if you choose 8 inches, you will see that now all the points has moved. So what we can do is, first of all, delete the image because we are not going to need it anymore. And then join the points because it will be easier to visualize what we are doing. So measure the distances of all the other points. Be careful, you see that this this line here, it's not perpendicular. This distance is not, this line that marks the distance is not perpendicular, is not parallel, sorry, to this distance. You have to be careful and select the distance when it is parallel. So now I click. Now, and the distance stays there. Okay, perfect. So let's do the same for all the other distances. Here, also here. Perfect. So this is the mechanism. This is one bar of the mechanism. This is another bar. Here, if you remember, will be the motor. So this is one crank. This is the other. Here we have another bar, and here we have another bar. But there were 3 fixed points, right? 3 points that were not moving, even though the mechanism was moving, which were this point here, this other point here, and last another point here. We want to know the relative position of this point. So what we are to do is, instead of selecting a line, we're going to select a center line. I'm going to build a triangle here, from here, here, from here to here, and from here to here. Perfect. And we are going to select, measure also these distances. And the last one. Great. So I recommend you put the distances in a place that you can understand them. So, for instance, this way, it's easier to visualize them. Okay. Now, and what we're going to do now, it's okay, I'm going to take a screenshot, and we are going to go back to Paint, to another document, because this will be our drawing. So put the image here, and we can even give names to the bars. For instance, this one here will be bar 1. This here will be bar 2. This here will be bar 3, and this here will be bar 4. So bar 1, bar 2, bar 3, and bar 4, and then we have the 2 cranks. Okay. So now we have all the dimensions of the thing we want to build. So we can save it. So we have seen the image previously. Now we can save the drawing. So drawing or dimensions, we can say. So every time we need to know the dimensions of the mechanism we're building, we can go back to this document. So I'm going to minimize it. I'm going to close it because we are not going to need it anymore. So close it. Perfect. And here you can see that I've made a folder with everything that we're going to need. So we have, first of all, made this screenshot of the drawing of the mechanism that we built in the previous video. Here you have the dimensions we have decided today. I insist, if you, instead of picking 8, you want to pick 4 or 12 or the distances that you want, all the other distances will be modified accordingly. So you can pick whatever you want. And here you can see that I have copied all the templates that you have on Canvas. So we will need some of them, but I am going to take one by one so that you don't get really stressed, because at the beginning, if you're not familiar with SolidWorks, there are a lot of things that you have to know. So I'm going to copy the base, which is the first thing that we have to use. So we have the base here, perfect. I'm going to go here to the SolidWorks, and I'm going to create a new assembly. So I press OK. Okay, and now they ask me to import a part. I select the base. And you can see that I can decide where to put it. So I put everywhere in the space, but I can. The first object that I put into the assembly will become fixed. We can move it later, changing some things, but to make it easier, just select the as the first document that you import into the assembly. Be careful that it to pick the base of the assembly. So we press here, and you can see that now it's fixed. I cannot move it. Even if I click here and I try to move, I cannot move it. I can change it by going here and saying float. If I float it, now I can move it. But to avoid having to do it and needing to do it, I recommend just work with the first object that you import fixed. So okay, we have here the first object that we're going to work with. Another object we want to work and we want it fixed will be the battery. So we can go again to the templates and select the battery part, copy it, and paste it here. So now we're going to insert the battery into this assembly. So we're going to press Insert Components, and now I'm going to select the battery. So as you can see, I can move the battery however I want. However, that's not, and wherever I want to put it, maybe I want to put it here. I can select, okay, so I want to fix it, and now I cannot move it. If I want to move it again, I can say float it. However, fix is not an elegant way because it can be floating, as you see. So to make sure that everything that we do is correct, let's float everything. So everything is floating. And now let's add some relationships. So this is the part that it's not moving, right? So we want this in a certain position with respect to the part that it's not moving. So what we're going to do is, for instance, I may want this surface and this surface to be parallel or coincident. So what I'm going to say, it's made here. With these both selected, selecting both of them, it's I press these two surfaces while pressing Control. So I do it, and I select made. And you see that the program by itself selects a relationship, in this case coincident. But you can pick another one. You can say parallel. In this case, it will be parallel, and you will be able to move it. Or you can say also perpendicular. So whichever you want. Usually the one that SolidWorks recommends is the one that you want. But of course, not always. So you have to be aware of that. So in that case, I select coincident. I may want also this surface and this surface to be coincident. So I select them. And as you can see, if this surface is coincident with this one, and this other surface we have selected is coincident with this one, now this body can only move this way. I want to fix it completely. So what I'm going to choose is select another another property, which is called, it's here in advanced maps, and it's called width. So to select width, you have to select two surfaces of the same solid, and then two other surfaces of the other solid. And it will, and the program will do is it will place the first object in between the two other surfaces. So for instance, I select width, I select this surface, this other surface, and then I select the other solid that I want to put this into the middle. So this other surface and this one. And as you can see, now it has been centered and I cannot move it. Okay, perfect. So we have our first two components. As you can see, the battery is much higher than the base. So maybe we want to expand the base. We can modify it. So you can see here that we have the base and the battery. We can go and open the base as a part. This is not an assembly now. This is a part with all the instructions that has been made, that has been given to create this part. So we can modify it. Another way of accessing, though, it's just if I want to modify the base, I click here and I click Open Part. So I can click Open and then say OK, and then say OK. So I want to make it higher. So you can hear that this operation has created this block here, and this other operation has created this one. This is the one I want to modify, right? So we can do it by selecting here, and instead of 150 millimeters, maybe 300, for instance. And that's it. Now we can save the part, exit the document, and you will see that now it says, okay, in the assembly, the models has changed. Do you want to rebuild them? We pick yes. And you can see that now the battery is here and the part has grown as we specified. Okay. Then you can see that I was working in millimeters. So whenever you open a part, you can decide the units you want to work with. So you can work with the international system. Well, it's not international system because we have grams here, but we can work with millimeters, grams, and seconds, or we can work with inch, pounds, and seconds. Depending on the distances, you may want to use one or the other. Don't worry, because even though you will be working on, for instance, millimeters, you can change at any point to inches. So don't worry about that. So what we can do also is, now we are in the assembly, no, we are in the part. So in the part, remember, if you are not in the part, well, now we are in the assembly, where there is everything, so I open the part. So what I want to do now is, you remember this drawing that we made? So I want to build these points, because these points will be located here, right? So I want to draw these points here. So what I'm going to do is select this face and then open a sketch in this face. And I'm going to locate the points. For instance, one here, and the other here. And I'm going to assign the dimensions that we said that this had to have. So for instance, this was 8.98 inches. So from here to here, 8.98 inches. Perfect. Now it's in millimeters, grams, seconds, but if we change it and we open the sketch again, you will see that it's the distance that we specified. We can do the same for this. 12.77. And for the last one, here, must be 554. As you can see, now I can move the triangle, but I cannot change the relative position of this point with respect to others because I have fixed the distances. So I may want to fix also this point because now you see that they appear in blue, right? So every time that you see a point in blue, it's because it's not fixed. You can move, you can rotate it. So I may want to fix it. So to do it, I will add some other relationships. So for instance, I will say that the distance from here to this line here, it's 10 inches. And the distance from here to this other line, it's 9 inches. You can see that now this point has turned black. But these are still blue because I can still rotate this. To solve this problem, what we can do is, okay, we could add another distance to solve it. Or what we could also do is say, okay, so I select this point here, and I also select this point here while pressing Ctrl. And I say, I want these 2 points to be horizontal. You see that now the only possible solution of all these conditions is the point located here. So finally, I will add some circles here. That I will use later to add relationships. So you can see that now, if we save it and we go back to the original assembly, these points have been created. So in this point, will be the motor. So in this point will be the motor that will be here. And in this point and this point will be these 2 parts of bar 1 and bar 4. So if you remember also, in the SolidWorks templates, we have binary links. We will need them, right? So what we are going to do is copy this binary link, and we're going to paste it here. So, but we don't need only one. We need 4, right? And each of them have different dimensions. One is this length, the other one is this length, the other one is this length, and have a different shape also. And the same for V1. V1 and V4, they have similar shapes. So we have to modify them. So here I will open it. And I will save it as link 1. Link 2. And the other one will be link 3. We will create link 4 from link 3. So right now I will not create it. So we're going to create it in a few minutes. So we can select, we can open the link 1. And as you can see, if you select it, here it shows the different operations that were made to create this link. So you can see that they, first of all, they started by designing this sketch. So you can modify it. For instance, I will exit first because I want to work in inches. So for instance, this distance was set in the template 394 inches. But in our case, for bar 1, sorry, wait a second, because bar 1 is the one that is modified. So we will start with bar 2. So sorry about that. Let me close it and open bar 2. So once again, we can modify it. So select it and work in inches. Now correct. And the second bar we want to be 4.89. So we modify this distance bar 4.89. Yes. And you can see that the distance has been modified, the length of the bar. In this case, I will also want to change it because we're not going to use bushings in this case. So we're going to select this to be 0.25. And the same for the other. So 0.25. We're going to do it for each bar. Be careful to modify the dimensions. I am modifying this bar and I modified the base and everything. I can modify some things, but only the things that we can build in the laboratory. For instance, everything that it's made with wood, we can modify it because we can cut it larger, shorter, or in different shape. But for instance, I cannot modify a screw or a thing that it's made by a provider. So in this case, we can modify it, but be aware that some things you may not modify, and you will have to find a way to work with what you have. So I will save it, and I will have finished with link 2. Now I want to do the same, but with link 3. So I go here, I open it. I want to work again inches, and then this distance has to be 8.54. 8.54. Nice. Yes. And this distance, this diameter has to be 0.25 inches, and the same for this one. Perfect. So now we can go back to link 1, which is this bar. And as you can see, it has 2 parts. This is like a normal link, but then it has an extension, right? Okay. So we can work from here. Okay. So what we have to do is go back and say edit the sketch. Perfect. So first of all, I would like to create a line from here and to here, let's say. But I want this line to be parallel from this to this line, right? So I select both lines by selecting first this line and selecting this other line while pressing Ctrl. So I do it, I select collinear or parallel, both of them work. Parallel. And now I can trim this part here. Okay. I will exit a second. Well, I will set this to inches again. And I will go back here because we want this distance to be 329. And the distance from here to the end to be 8 inches. Perfect. You can do the same for this other bar here, but you can also mirror entities. So you select this line and say, okay, I want to mirror it with respect to this center line. And you can see that we create another line here. I select it and then I close the object. Finally, you can see that not all the surface is blue, right? So here is white. That's because the program doesn't know what to do with this line here. So what we have to say is, okay, don't worry, just 3 entities, and I will cut this. And now, if we press exit sketch, the object, will rebuild correct in a proper way. We can also add a fillet here, so we can select here and here, and add a fillet of maybe whatever you want. It's 0.2. And now we can exit the sketch and see if the part has been created, modified, properly or not. So I exit the sketch, and we can see that some errors appear. That's because we have modified this operation that was before this other operation. So what you can see is, okay, let me modify it. And you will see that here we added a fillet. Here there was also a fillet, but when modifying, when adding it, the information for this fillet has been lost. So we just delete it and just add it again. The same with the other ones. And you can see that we have created this bar 1. We only have to create the bar 4. So we just save it, and now save as in a link 4. And we modify the dimensions, but for link 4. So this is 342. .91. Okay, and you can see sometimes the dimensions will not be actualized at the moment. So what you can do to solve it, it's okay. I won't be able to do it because create this traffic light here, and then it will be, yes, you can see that it has changed a little. Now it has actualized the dimensions. Okay, so once I've done it, I can save it and exit. Save it, exit. And now we can start building this mechanism because we have all the dimensions here, imported here, and also the bars built properly. So the first things, so we're going to build the object from here to the end. So the first thing we need is to build the motor. By the way, now that I think, I have forgot something in some of the bars. These are correct, but as you remember here, I told you that we wanted this dimension to be 0.25. This other dimension to be also 0.25. And the same for link 4. Come here, we select this diameter, this other diameter, and change it. Perfect. So if we have to start from here, the first thing we have to add is the motor, right? So we go to the templates, we copy the motor, we paste it here. And then once in the assembly, we select insert components and insert the motor. So I'll put it here. For instance, we're going to move it. So we want this surface and this surface to be coincident, right? So we select this surface, select mate, and we select this other surface, and now they are coincident. We also want this surface and this circle to be concentric. So we select them both, and now they are concentric. You can see that now, even though we can move the motor, this will be concentric. Of course, later, or now, we can do it now if you want, we will have to add a hole here, because right now it is like transpassing, like a ghost, so we need to solve it. In my case, I don't want this to be rotating because the motor has to be in place. So what we can do is say, okay, so this surface here and this other surface here, I want them to be parallel. And now the motor is completely fixed. It has no degrees of freedom. So let me. Okay, so we need a hole in the base, this point that has these dimensions. The dimensions of this, right? So to measure these dimensions, first of all, we go to inches, and we can say evaluate, measure, and we can select this, for instance. We can say, okay, the radius is this. We don't have to remember it. We just have to copy it to the clipboard. Now I have it copied. And now we can go back to the assembly, open the base, and say, okay, I want this distance to be the distance that I copied, which is this one. So I press enter, and you can see that now it has been modified. Just to be faster, I will also tell you that we want these dimensions to be 0.25. You can do the same, or you can say, I mean, you can give the same dimension here, but another trick is select this one, select this other one, and say I want them to be equal. And you can see that now everything is black because everything is defined, the position and the dimensions. So we exit the sketch, but not only that, but what we're going to do is go to features and select cut. So it will what this operation will do is it will cut this surface in one direction or the other. So we select cut, we select the sketch that we defined. Sorry, we select the sketch first, and then we go to cut. And you can see that now we can cut from here to this direction, or if we flip the sides, to the other. Of course, it makes no sense to cut to the other side because the sketch is here. So one way, there are different options. You can say blind, and then you select the distance, or you can say through all. So it goes from the point that you specified to the point, to the latest point of the object. You can say also up to surface. So you have to select this surface, for instance. All of these options are correct. So if I select up to surface, you can see that we will have created, sorry, these holes here. Now, if we save it and go back to the assembly, we actualize it, and you can see now that we have created a hole here, here, and here. However, I wanted this to be, wait a second. Oh, sorry. Let's measure it again. Okay, I know what happened. Here we measure the radius. Copy it again. But when we went here, when we made the holes, when we set the dimensions, the radius was given, but it has to be the dimensions of the diameter were given the dimensions of the radius. So we had to multiply the radius by 2. So, and now we get the proper dimensions for the hole. So we save it, we actualize it, and now you can see that indeed this hole is big enough for the motor. In fact, it has the perfect dimensions. So once we have it, what we're going to do is start importing the bars. So let's continue with it. Sorry, I have to pause the video. Remember also to save the assembly. So I'm gonna go here, File, Save. I'm gonna save all, and I'm gonna select the same folder where I have all the parts. Now you can see that I have the assembly here. Just to mention, if I change the name of any of the parts, the assembly will not be able to find the part later, and you will have to insert the parts. It's just like a PowerPoint presentation with videos, for instance. If you change the location of a video, when you open the PowerPoint can find that video. Or if you change the name of the video, the same problem will happen. So in this case, it's the same, so be careful about it. Okay, now what we need is the wheel hub. So we copy it, we select, we paste it here, and now we will insert it. So insert, okay. Sometimes when you open a part and then move it, when you try to open it again, SolidWorks is problem. So what I recommend is closing SolidWorks and then open it again, and you'll see that you have no problem. Okay. So open the assembly. Now insert the part, and you see that I don't know why. Sometimes this happens. So we will select this face and this face here, and we're going to make them. We want them to be coincident. But as you can see, they are coincident now, but we want the opposite side, right? We want them the other way around. So we can choose either this or either this. If I select this, you will see that the relative position will change. So I press, and now it is the relative position we want, right? So I select OK, and I want this and this to be concentric. Perfect. You will see that this will be rotating, right? So right now, this surface and this object and this are not colliding. However, in reality, the distance will be so close that we could have problems. So if we wanna be strict, what we have to do is go here, open it, and then sketch another hole which is bigger, just to avoid problems with friction. And then make a really small hole here of maybe 0.02 inches. You will see that that may be enough. I don't know. We will have to try it in reality. So if we save it, I'll go back to the assembly. This way we are sure that this part here and this, they are not colliding. If we wanted to be more elegant, we can get this distance close to this. So if we measure this distance, when we open this part, we can select, instead of 1 inch, select it to be 0.6. And as you can see, now it is more elegant. So what we will do now is insert the first crank. So we're gonna go here. We're gonna select the crank and copy it into our folder. Now we're gonna insert components, and we're gonna insert the crank. We're gonna insert first the crank that is joined with this part. So we are doing this crank here. So we have it here, and now we're going to add relationship. So we want this. I mean, this will rotate once we put a screw here. It will rotate with the shaft of the motor, right? So we want this to rotate with this. And that's the reason why we have this point. So to do it, we're going to select this surface and make it coincident with this other surface. Now we're going to do the same, make this concentric, but now we want this and this to be concentric also, right? So we press, we accept, and now you can see that this part and the crank are rotating simultaneously. You see that? Perfect. We also, as always, I want to open this part and modify the dimensions that are to the ones that we want. So we open it. Okay. And first of all, we want these diameters. Let me first work in inches, as always. Okay. We want these diameters to be 0.25, right? And the same for this one. And we want the distance from here to here to be 0.71, right? Yes. But unfortunately, when we designed this part, we didn't specify the distance from here to here. So you will have to do it. Well, how do you do it? You stop on the sketch, and then we will get rid of this part here. So we will trim entities, and we will get rid of this. So what I have pressed, I can cut surfaces, and all the surface that are cut will be deleted. So you can see that now when I cross this circle, it will disappear. So I press the mouse, I go through here, and this surface disappears. Okay. Now we're gonna fix this point. So we're gonna select it and say fixed. And the same for this one. You will see that when I fix it, this surface, this line, sorry, becomes black, because as I have fixed it, now I cannot move it. On the other hand, if I move it, this will move. I won't do it because I want this in that position. In fact, let me also fix it. Or maybe not. This just happened because this part was done from another part. So you can see that here there are dimensions missing. So if I add some additional information like fixing a point, the sketch could be overdefined. That's what happened. So don't worry about that. Just don't touch it, and we will be fine. So we need to build a line from here to the other side, but that crosses the center of the line that joins this point and this other point, right? So, well, that's not a problem. We just create another center line that goes from here to here. Perfect. And now we say that this line has to cross the center point. So we press it. Now we say they have to be coincident. And you have seen that now this line, we can extend it, but we cannot change its direction. And we want this line to be 0.71 inches, which is really close to here. So we may have some problems, but nothing that we can't solve. So we will create a circle here, and we will say that this circle and this circle has to be equal in dimensions. Perfect. And finally, we will add here a circle. And we will say, for instance, that this has to be 0.5 inches, or even more, I don't know, whatever you like. You are free to do it because it's your part at the end. It's wooden, so you can design it as in the shape that you want. So 0.7, yeah, for instance. Now, you can see that cutting this part will be complicated. So what we can do is we can create a line here. You see this blue line that has appeared now. If I make a line now, if I select the line, you will see sometimes that this point is not fixed because I already added some relationships. So be careful when you create a new line to not start or end a line where any of these lines are made if you don't want them. So I don't want it, so I select, for instance, this point, and I finish this point, and that's correct. And I will do the same here, and you will know, and you will understand why in a second. So, for instance, here, perfect. I will say I want this line and this line to be tangent. And I want this line and this other line to be tangent too. And the same here. And what I can do now is trim the entities that I don't want. So I don't want this line. You can see that when I cut it, it will cut all this line out until the next entity. So I cut, I don't want it. I don't want this anymore. This, I don't want it. The same with this, the same with this, the same with this, and the same with these three. And the same with this small one. You see that the surface has not turned blue. That's because there is this little one that if I cross it and I cross this and this, now it will be defined properly. So now if I exit sketch, you will see that we have created the structure that we wanted. So now we can import it. We can save it, and this disappears. Perfect. And now you see that this works perfectly. So many of you may think, okay, so now I have this crank, then I just put the other crank in the other direction. That will not work in this case for this reason. So as you can see here, if you put in the same plane this line at this line, or even in the, if you don't put them appropriately at this point, now they will collide. Even if you build that in different planes, one of the two lines will collide with the axis of the motor in some point. So to solve it, what we're going to do is we're going to do something similar than this. Here. So you will see as we do it. So first of all, from here, we will attach the third bar. So we need to insert components. Sorry, between bars. Yeah, I was missing something, and I just between bars we will need spacers. So we copy it, we paste it here, and now we have a spacer. We're going to modify it. We should not modify it, but I know that we should not modify because this is a part that we buy. The problem is that the spacers, there are many types and many dimensions, and you only have one type in the folder, but I know for sure that in our lab, there are other dimensions, and in particular, we have a spacers with these other dimensions. So let me work with inches, and we have a spacers with a diameter of 0.25 0.25. This distance 0.5. Perfect. So we will work with these spacers in this project. So we're going to go to insert components, and we're going to insert the spacer here. And we're going to make this and this concentric. Perfect. And this face and this face coincident. Perfect. You see that now it is starting to work correctly. Perfect. So now we're going to insert the third part, right? Okay, so let's go here, insert components, the third part here. Okay. So we go here and we say this and this surface has to be coincident, but not in this side, on the other side. So we change the orientation. Perfect. It goes there, but it doesn't matter because now we're going to say, okay, so you have to be concentric. Perfect. And you can see that now, it is difficult if we don't think of an alternative way, if we build the other bar here, it will be collided at this point with the other bar, with bar number 2, right? So we have to be careful about that. Okay, but right now what we can do, anyways, is we can insert bar number 4. So first of all, we need the spacer, so insert component, another spacer. This and this. No. Select this and this, and they have to be concentric. Perfect. And then select this face and this face, and they have to be coincident. Perfect. And now let's insert the link 4. So no, not made, sorry. Insert components. Let's go and insert link 4. So this part here and this part here has to be concentric, and this part here and this part here has to be coincident. Finally, this part here and this part here has to be also concentric. Now, you can see if we rotate the link, now we have the first movement. Of course, you can see that this is not what we expected, right? But there is no problem because we defined these points with respect to the base, right? So we can open the base and modify it and say, okay, I want the base maybe 2 inches taller. So instead of 12 inches, maybe 13 inches, 11 inches, sorry, maybe 13 inches. And this point here, instead of being 10 points, maybe 12. Oh, sorry. Distance of 12. Equalize it. Okay. Looks weird, so let's make it even higher. So let's make it 14. Perfect. Save it, and let's go back to the original. And you see that now it is perfect. We could even lower it a little bit. So that's as you want. The problem is here that we have also to define this. So we have to go back to the part because we have modified this length, but we define this later, right? So we have to go here and redefine this sketch. So say, okay, this point, or maybe this circle, and this other circle to be concentric. Exit the sketch and problem solve. So we go back, yes, again. Okay, and now we have the first part of the mechanism built. Now what we will do is create the second crank. Instead of going from the motor, it will go from here. But it has a problem because you can see that the relative position of this crank with respect to, of this bar with respect to the crank, it's not fixed. You see that the angle is varying whenever it rotates. But in the GeoGebra model, you can see that this crank and this crank, they are also collineal, right? So this line and this line, they are varying the angle. But this line and this line, they are collineal. So if we want to build the second crank instead from here, but from here, we have to find a way to translate the movement instead from here to here. In other ways, what we need to do is a way of transmit the relative position of this crank to the crank that will be here. So how we will do it? What we will do is, okay, so inside this hole will be a bar, such like this, a brush tube, that is just to avoid friction problems. But as you can see, for instance, if we created a hole here that went all the way inside until here, for instance, then the brush tube that will be inside will be rotating at the same pace, at the same speed that the crank. And if we make another hole, here there is a hole for the crank, and if we make another hole here for the second crank, then the two cranks will be in phase, because the first crank will transmit the movement to this bar, and the bar will transmit the movement to the other crank. I'm sorry if I didn't explain like really clearly, but you will see really well how it works when we build it. So we will start by making the hole here. So we have to edit this part, so we will open it. And I want to work in this plane, in a plane that goes from here to here, right? Because the hole has to start here and has to end here. So how do we do it? So let me remember, because I'm not sure. Yes. So we're going to create a sketch. And what we're going to do is, okay, so I can build something like, for instance, here, But sometimes the things that I want to build, it is already in the sketch, right? I mean, so it's already built. So in this case, what I want to do is I want this circle and I want this other circle. But as you can see, right now they are not in the sketch. But if I select the circle, and select convert entities, now you can see that the circle has appeared. And I can do the same here. Oh, sorry. So convert entities and convert entities. Now, I don't want to do anything with these circles. I just want to use them for construction. So I will just mark here. You can see that now it is blue because it says, oh, maybe it want to extrude something or cut something or do whatever it wants to do. That's what the program is thinking. But if I press for construction, it say, okay, he doesn't want to do anything. The program will say he doesn't want to do anything with this hole. It's just for construction. So what we're going to do is, okay, so add another line for construction, a certain line, and say, okay, there is a line here. Now we're going to build a line that is perpendicular to this one. And we're going to exit the sketch. Because what I want to do is I want to create a plane that goes from here and that is perpendicular to this surface. You see? Nice. So I say okay. And I will select this plane and I will open a sketch in this plane. And what I will do is I will convert these entities into this plane, and the same, I will convert these entities into this plane. I will use it for construction, the same here, and I will add a center line from here to here. You can see that this point here that sometimes appears is the point that is completely centered in this hole, both in this hole and this distance, right? So we want to build our hole from here. So we are going to do a circle from here to here. And we're going to say, okay, dimensions 0.1 inches, for instance. And now I'm going to cut a hole. So I'm going to exit the sketch, select the sketch, and cut. And we're going to cut in this direction, maybe 0.3 inches. And in the other direction, we're going to select this other direction. We're going to cut everything from here to here. We're going to select this plane and hide it. So, and we are also going to hide this sketch. Sorry, not edit. Perfect. So if we save it and we exit, you can see that now this hole is has been created, sorry. And that if we put a screw in this hole, that will mean that the tube that will be inside here and that will be skewed by the screw will rotate at the same will have the same relative position, of this hole here, right? So sorry, let's continue and you will see it because I am explaining it really poorly. I know, I'm sorry about it. So let's close this. Okay. Let's insert another spacer here. This face and this face has to be coincident, but on the other side, perfect. And this and this has to be constant, perfect. Now here we're gonna insert the other crank. So for the other crank though, we're gonna use a binary link, and we're gonna modify it for it to be a crank. So we're gonna paste it, and we are gonna say crank modified. We're gonna open it. So the length of this other crank, if it goes from here to here, it has to be 0.71 plus 0.71, right? So the distance in inches has to be 1.42, which is 0.71 plus 0.71. And we will do the same here. So this is easier because in this case, we have a plane here. And we can build another plane if we select this. Sorry, if we sketch here something and we say, okay, I want to convert entities, not this. If I want to convert this, we use this for construction. Now we can build a line from the top. You can see that now we have points here, right? In the other part, we didn't have points. In this case, fortunately, we have. So now what we can do is, okay, exit the sketch and say, I want to create a plane that crosses this line and is perpendicular to this surface. And we can do the same. First of all, we're going to hide this. And now we're going to open a sketch in this plane with this plane selected. Open a sketch. And then we're going to convert these entities, this here, and this other here, and we're going to use them as a construction. So we're going to use them as construction, for construction. We're going to create another line from the center point to the center point. Now we have the point that we want. So we're going to create a circle that has to have the distance 0.1, which was the distance that we decided in the other one. Sorry, I need some water. So the same than before, we're gonna now cut in this direction. We say that through all, and in the other direction, we say blind up to 0.3 inches, right? Okay. Perfect. So now we're going to insert it. So we're going to insert crank modified, which is this one. I'm going to say, okay, this surface and this surface has to be coincident, right? But on the other side, whenever you do something wrong with a relationship, with a mate, you can go back here. You have all the mates of the documents. So this is the last one that we built. I can edit it. So I just select it. Say, okay, I didn't want it. I just wanted the other one. So, and now it's solved. Now I want this concentric. Perfect. Oops, no, this and this concentric. Now yes. And you can see that I have not achieved what I wanted, right? Why is that? Because there is some relationship that is missing, which is the following. So do you remember that I wanted that the tube or the screw that we put here transmits the movement to the tube, and the tube that is inside all these structures transmits the movement to this. So we want this bar here and this crank to be completely in phase, right? So what I will do is, okay, I want this and this to be like in the same relative position. So first of all, what I will do is I will try to get close to the position that I want. So this will be like an acceptable position, right? Okay. And now we need, then this and this are parallel, right? Or even better, now that I think, the planes that we created here, this plane do you remember this plane? It was, I will open this plane here, the plane that we used to define this hole, right? So this plane here and this other plane here, which is the plane that we use to define the hole of this crank. So the plane that we use to define the hole of this bar and the plane that we use to define the hole of this crank, they have to be parallel, right? So we select this plane and also this plane and say, okay, we want them to be parallel or coincident. We can either select parallel or coincident. You see that it's the same, right? Okay, so coincident. And now you see that whenever I rotate this, the other rotates accordingly, which is exactly what we wanted. I forgot also, sorry. I also forgot to change the dimensions of the holes. So we go back here and we modify this to be 0.25 and the same here. And now we can add the rest of the bars that we need. So for instance, now we are missing bar 2 from here. So first of all, we add a spacer. So insert components, spacer, and where did it go? Here. Okay. So I want this face, this surface, sorry. and this surface to be coincident, and I want this and this to be concentric, right? We could also put the spacer here if you want, but I want this last leg to be in the same plane that the last leg of the other. So as you want, it's your choice. So now we will insert the second bar. So this has to be coincident with this one. And this to be concentric with this one. Perfect. And finally, we're only missing bar 1, right? So we first insert the spacer, and we also insert bar 1. Remember, this and this has to be coincident, but on the other side, yes. And this has to be concentric. Perfect. Now this. Sorry. This and this has to be coincident, but on the other side. And this has to be concentric, which is the same. Sorry, and on the other hand, this and this has also to be concentric. Perfect. Now you see that the mechanism works perfectly. So if we start rotating this, the mechanism will be moving as we planned, right? Okay, so now there is only a few things left, which is remember to save the document just in case something happens. And the only thing we have missing is, okay, so we need to insert the bars that go here, right? And we also need to put the screws and everything. So maybe I should have put them before, because now they are a little bit hidden. We need some screws here, right? Because the movement from here, I mean, the motor gives the movement to this part. This part gives the movement to here, to this crank, sorry. And the crank gives the movement also to the bar that goes inside all this. And the bar that goes inside all these holes gives the movement to this. And then both this crank and this other crank give the movement to the rest of the mechanism. Of course, we need something to keep it all together all the time. So what we need is we go here, and first of all, we need this screw and also this screw, so we can copy them both. So we copy them and we paste them here. And the same for the bar. Well, sorry, we need the brush tube. Unfortunately, for the brush tube, we will need different distances, right? So here we need a brush tube that has a distance of 0.7575, so this distance, right? But in here, we need a much larger tube, brush tube, right? So we will need to create different versions. So let's open this. and change the distance of the extrusion. Sorry, so we modify it, and instead of 200 millimeters, 0.7575 inches. Perfect, and we save it. Now we will also need another brush tube of distance from here to here, right? From here to here. So we will need this distance. So we go back here. We save it as brush tube 2. And we added the distance of extrusion. And now, finally, we also will need save it. We will also need an other length, which will go from here to the other side, right? So a total of 2.29 approximately inches. So we go here, we save as the third one. And the distance will be now, oops, the one that we selected. Okay, so now we save it, close it. I will modify this and say that this one. And we will start inserting everything that we need. So file, sorry, assembly, insert components. So we want this one. That is concentric to this. And this face of the brush tube that is coincident with this. Perfect. The same in this part, right? And the same here. So we need two more. So we will insert the same one for here, another one for here. Okay. And now let's add the relationship to go faster. Okay, so this has to be concentric, perfect, and this and this has to be coincident. This and this has to be concentric, and this and this has to be coincident. Perfect. Let's also add these ones. So this and this, no. Now yes, this and this have to be concentric. And this part here and this other here have to be coincident. Perfect. And here, this, the surface, the surface to be coincident. Perfect. Finally, this concentric, and this. Perfect. So you see that if you make a hole that goes from here and goes all the way through this brush tube, then the brush tube, the relative position of the brush tube with respect to this bar will be fixed. And if we do the same here, then the relative position of the brush tube with respect to this crank will also be fixed. Then the relative position of this bar and this bar, the crank and the other crank slash bar, will also be fixed. And that's the reason why we made this hole. Here, we will put a screw or a bar, or we will put something here that makes that the relative position of this bar with respect to, with respect to this bar, it's the same all the time. And the relative position of this crank and this bar, it's always the same. And this way, we will achieve that this and this are always in phase. While, for instance, on the other hand, well, on the other hand, you see that this and this are not in phase in this on this. I paused for a moment because I just realized that this bar is colliding with this other, right? So remember when I told you like some time ago that we could choose to continue with this bar in this place or in the other place? Where if we continue in this place, this will collide with this, which is what we wanted to avoid, and the reason why we made all this hole here and everything. So I will have to delete the relationship of these bars, of this bar, to put them into the other side. So I select this bar, and so all the relationships, and I will keep the concentric ones, but I will delete the coincident ones. So I select them and I suppress them. Yes, yes. Okay. I will do the same with the spacers. So I select the spacer and I go here, view mates, and I select the coincident to delete it. The same with this one. And the same with the brush tips. Of course, if you pick the other side and you have it correct, you don't have to modify all this. But you are as smart as that I do. I mean, if you do the same errors that me, I mean, you will have to modify it. So select the brush tube. This is the last thing that we have to edit. Edit, yes. Okay. Now you will see. Now we can move this here, the brush tube. We can also move this and this. And we can very easily solve everything. So this, and this to be coincident. Perfect. Same with this. And this. Perfect. Incident. Coincident. And coincident. Perfect. Finally. Now you can see that there is no collision. Right? In fact, it's just similar than what we have here, right? So remember this. This is pretty similar than this, isn't it? Okay. Perfect. So just a few more things. So we need to add the screws. So insert components. Let's try to go a little bit fast. One of those. Another one of those. And another one of those. I want this face. I want this face and this face to be coincident, but flipped. Perfect. I want this and this to be concentric. Perfect. And the same with the other two. So this face to be coincident, but on the other side. So now, yes. And I want this to be concentric. Perfect. The same with this face, this, and this. Perfect. Okay. You can see that this is here now. This is because we have inserted a part that has text in it. We can ignore it, so we can go view, hide and show. We can, I think it was this one. Yes. So if we select this, we can change it. And if we select hide everything, all the sketches will also disappear, as you will see. So whatever you want. Okay, and now we should also put one of those here, right? So, but we will need longer ones, right? We will need a longer one that goes from here to here, and then here we put a washer to prevent this to move, to go away, right? The same here, sorry. The same here, the same here. Here we will need a really long one, right? The same here, and the same here. In that case, in this particular case, we don't need anything here because this brush tube is not going anywhere. Why? Because we will have one screw that goes from here and that goes all the way this brush tube. So the tube will be fixed and the same in the other side. So we won't need one screw as in the other side, as in the other parts. So we need a screw of different dimensions. We'll go to SolidWorks templates and we'll change the name, and we will copy it here. We have to change the name because if we copy it here, we already have it, right? Because this one that we have in the folder are these ones that we have created here. I want a new one because I want to modify its dimensions. So I will copy it here. I will open it. And then I will modify its dimensions. So right now, you can see the first one, I can modify its length, right? So which length do I need? Of course, I cannot invent any length because these things you have to buy them in a store, and they have only some particular length. But let's assume that we can pick whichever length we want. So for instance, we need a length from here. Evaluate, measure. I want to know the length from here to here to here. From here to here. I don't know why it's not letting me do it. Let's open the brush tube. It's easier. If you remember, we have the dimensions that we want here. So we copy it. We go here. And now we change its dimensions, make it a little bit longer, the same dimensions that the brush tube. So instead of 0.75 inches, the distance that we copied in the brush tube. So we select OK. And you see that now it's longer, right? We can even make a little bit longer because this will be the thread, and in the other part we have to put the washer, right? So to modify it, and instead of 0.75, maybe 0.8, I don't know. But I mean, as we're not gonna build it in real life, we can be inaccurate. But in real life, of course, we will need to select a screw that it's one of the dimensions that we can buy in the buy in the store. So we save it. Okay. Now, what other dimensions do we need? So we come here. Okay, this will go here, 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 and we need another dimension for this part. So we select this, and we measure from here to here. Now it's letting me, so perfect. Copy this dimension. We go here. Save as another one. So save as number 2. And the dimensions now, it has to be, no, not this. Yeah, a little bit more. So instead of 0.28, maybe 35. I don't know. Let's try. Okay, so save it. Go back to the assembly, and let's insert everything. So assembly, insert components. We will insert these ones. We need 3 of them. One from here, one for here. Sorry. Another one here. Another one here. Another one here. And finally, another one here. Perfect. Now, let's give some relationships. I need to move it first. Okay. So this coincident. change position, perfect. And this, perfect. You can see that we make it a little bit longer just to put a washer here. Perfect. So now this, coincident, and this, concentric, perfect. And as you can see here, we have also space to put the washer. We can make the space large if you want, so as you prefer. So this one, and this one, this one, and this one. Oops. Let's try it again. This one. Perfect. Here we don't need it, remember? Now, this, and finally, let's do it again, try it again. This one and this one, yes, now yes, the other, perfect. Nice. So now we have finished. So if you want, we can design the hexagonal washers that will go here, that will come here. We don't have to make the helicoidal cut. We just make it's very easy. So for instance, of course it will not be accurate. So we will have to find something that we could buy in the store. But for this project, we could design one ourselves. So close everything, not close or minimize. So file, new. Let's create a part. Let's save it as hexagon. Let's work in the front plane. So we sketch an hexagon here. Okay. Inside the hexagon, we need a circle. So what's the diameter of the circle that we need? We come here. Okay, so the diameter will be this one, right? So we select this and ask for the dimensions. Copy the diameter, and we go back to our drawing. And this will be this dimension. If we go to inches, the dimensions that we specified. If you are a little OCD like me and you don't like things in blue, you could also say, okay, I want a center line from here to here. It's just to define everything completely. So we select this line and we say, okay, I want this horizontal. Now I can make smaller or bigger the hexagon, but I cannot rotate it because this line has to be horizontal. And finally, I can set this dimension to be 0.13 because why not? And now let's extrude it. Say, okay, this is going to be 0.1 inches, 0.05. As you want. As I said, this is not an accurate washer. It's just something to make the assembly look prettier. So we close it. Now we go here and we insert the components that we have designed. So insert one here, insert another one here, insert another one here, another one here, one last one here. And let's add all the relationship that has to be added. For instance, this face and this face, coincident, this and this, concentric, this face, this, coincident, and this, concentric. This face, this coincident, and this concentric. And that's it. That will be the mechanism. The last thing we could do is add a video of it, which I think it's required. So you can see that everything is in place and everything is moving accordingly. That's perfect. And now to add a video, it's really easy. We just go here and just go to motor study and just add a motor. So we click here. We have to select which thing is the motor. The motor has to be rotating, so you can't select this because this is not rotating. The motor the thing that you have to select is all the things that will be rotating with the one of the things, sorry, that will be rotating with the shaft of the motor. For instance, this will be rotating with the shaft of the motor. This will also be rotating with the shaft of the motor. This will also be rotating with the shaft of the motor. But you cannot select this or this part because this, I know that the movement is caused by the rotation of the motor, but it's not in the it doesn't have the same rotation axis as the motor. So we can, for instance, select this, and you can see that here the speed is 100 revolutions per minute, which is really high, but we will accept it and then we will change it. So we accept it, and now we press calculate. We could, instead of 5 seconds, we can make 12 seconds, for instance, and now press calculate. If we press play, you can see that now it moves perfectly. It moves really fast. So what we can do is pause this. You can go back to the origin and say, okay, I want that this motor, you select this blue one and edit. Sorry, you select the motor and edit it. And instead of 100, just say 20. Accept. And now if you press calculate again, you will see that the movement is much realistic. Well, realistic. I mean, if it is a horse, I don't know. Realistic is not the word. You understand, right? I mean, it's you can appreciate better the movement. So if you press now, it's more like slow. There is also a very nice trick, which is adding different, because right now we are getting like a general view, right? Maybe we want to show something specific, or we want to show different views. So what we can do is right click here and select disable view key creation. Nothing will happen when we do it, but now we are here, right? When I move the position, you will see that here it will appear something. So I change it from here to here. And you see that now it has appeared this. If I press calculate again, you will see that it goes from the original position to the final position. So it interpolates the movement between two different positions, between this position and this other position. Of course, you can go in the middle. This is the time. So you can go in the middle and say, okay, so in the middle, I want to be here. I don't know, here. And then at this point, so at this point, I want to approximate here so the professor or whoever is seeing it can see perfectly how this works. So just select here and then calculate it. You can see that now goes from here to here, as we said, and then here it will start approaching it. And that's it. Now, if you want to save the video, you just have to press here, save animation, and select the size and the frame and the type of file that you want to create, and that will be it. Well, so thank you very much for this for watching this very long video. I hope that it helped you understanding a little bit more SolidWorks and that you succeed in doing it. Well, thank you very much for everything again, and see you in the next video. Bye. Okay. Hi everyone, I'm Pol again, and today we're going to learn how to modify the mechanism that we built in the last video to adapt it to the requirements, to the exact requirements of the course. So I want to apologize because I didn't know that we could 3D print the spacers, and that was the reason why I didn't want to use some parts, and also I modified the spacer that was the dimensions of the spacer that was in the Google Drive folder. So now we have to modify something. Fortunately, it won't take a lot of time, I think. And that way we can also learn that even though we have finished a project, it is possible to change a lot of things without that much work. So first of all, we have here our assembly from last time. So I'm going to open it and copy everything and paste it into a new folder. In that case, in case something goes wrong or we get stuck or something, we have at least a backup copy. So I will create everything here, is here, and I will open the assembly. Perfect. So what we have to change is that here I didn't use a bushing, right? We have a bushing in the Google Drive folder, and we need to use them. And it's to increase the stability of these links. So right now the mechanism works perfectly, but because it is in a computer. But in reality, there is friction, there is tolerances, and that could mean that the mechanism doesn't work as planned. So by adding some bushings and changing the way that we keep the link together, we can improve the performance of the mechanism. So we need to introduce them, and to introduce them, we need to apply a lot of changes. So we will start from the beginning, which will be removing everything that we don't need. Just for you to know, I have made a list of all the things that we have to do. You will see that it's faster than it looks. So let's start from the beginning, which is eliminating the parts that we don't need, which will be the screws, the tube, the spacers, and also the hexagonal parts that we don't need anymore. So we can go here and eliminate one by one. It is gonna ask if we are sure that we want to eliminate, because there is a lot of relationships that depend on this, but we're gonna say yes. And another way of doing it, though, would be just going here and selecting all the brass tubes and deleting all of them. So delete, it's going to ask for each one. We're going to say yes to everybody, and bye-bye. Another one, so all the hubs, the wheel hubs, the wheel hubs screw, sorry, we will also delete them. Apart from these three, I want to keep these three because these ones are good in the place they are. So all the rest, we're going to delete them. So this I'm going to keep it, I'm going to keep it, and we're going to delete this one, this one, this one, this one, and this one. So, perfect. Then the spacers, I want to eliminate everything but this one. Because in between the spacers and the bar, now we're going to put the bushings. But here, we are not going to put it because we don't need it. So we're going to select all the ones that we want to delete, which is this one, this one, this one, this one, and that's it. And finally, we also have to eliminate the hexagonal parts. Perfect. And we have done the first part. Perfect. Let's go for the second part, which is solving the relationships, because we have eliminated some of the parts that had relationships with other parts. So right now, for instance, I can move this bar, and it is not linked anymore to the other bars. So we need to solve it, right? I recommend you start with the first one. Okay, and we can see that this and this bar and this bar are not concentric anymore, right? So we are going to select this and make them concentric again. Perfect. Let's try again if it is correct. Okay, we see that this and these are not correct anymore, right? So select this to make them concentric. Perfect. What if I change this? Okay, we can see that we have the same problem here, right? So select, and problem solved. And let's, in a front view, let's see if it works now or not. Yes, we can see that at least this part is working perfectly. We are only missing this relationship here. So we add it. And let's see if now it works or not. Yeah, it looks like it works perfectly, right? Perfect. Of course, everything is floating because now we don't want this close to here because it will be separated by a bushing and a spacer. But at least if we make a frontal view, everything looks perfect, right? So that's what we want. So we have solved the relationships. Now, For the bushings, we will need the initial diameter of these holes. The ones that I made you change in the last video, yeah, I'm sorry, we have to change them back. Sorry about that. So we're gonna go here. We're gonna open one of the links for the templates that Professor McCarthy has given you. We're gonna open the binary link, and we're gonna measure. When it opens, we're gonna measure what's the diameter of this, which is this distance in centimeters, in millimeters. We can change it to inches if we want. But it's a more difficult number, so I'm gonna stay with millimeters. So copy this number. Perfect. Close this because we don't want it. We only wanted the dimensions. And let's go by Y1, changing all the diameters that we need to change. So we will open this one, changing this distance and this distance. Okay, save it, and we close it, and it will be actualized. Perfect, the same here. So we open, and we resize it again, the same way. Save it, and close it. Yes, perfect. Now with the other bars, open, resize it, save it and close it. This one also. Remember that some bars, to actualize them, you have to press the traffic light that there is here. I don't know why sometimes you have to do it or not. I don't know. So it's save it, close it, actualize it, yes. Okay. So we also need to actualize, but here you see that we won't need a bushing, right? Because here this will be totally fixed with the rod, so we don't need movement here, and the same here. So this hole and this hole, we don't have to resize them. We only have to resize this hole. So we're going to open this part, and we are only going to modify one of the parts of the holes, which will be this one. Change it, save it, and that's it. Perfect. So we have done this part. Now we're going to introduce the bushings. So how many bushings do we know? Do we need? We will need one here, one here, one here, one here, one here, and one here. So 6 in total, right? So let's go to the templates, copy the bushings, paste it here, and we're going to introduce 6 of them here. So insert components. Okay, so first one. Second. Okay, and let's add all the relationships that we want. So we want one here, so but the other way around. Perfect. And whoops. And we want that this face and this face are coincident. Perfect. So let's see that here now this pushing will make that this move much smoother. And also in this place will be put the spacer, which will be joined to this other part. Okay. So let's do the same with the other. So we need one here. Another one here. That way. This face. Perfect. Let's continue. We need another one here. The other way. Another one here. And the last one, which will be here, right? So we select this, we select this, perfect. Select this, and we select this. And now that I think, we will also need to get rid of this, because you'll see that there is the diameter of this, of the inner diameter of these spacers is colliding with this bushing. So we need to get rid of it, which is not a problem. So we will just select it and get rid of it. Of course, now some relationships may be lost. So let's see if they are lost or not. Yeah, it looks like right. So we're just gonna select them and say that this and this must be concentric. Perfect. Let's see if it works or not. Perfect. It's working. Okay. So we have inserted the bushings. Now let's introduce the screw heads. So we come here. We didn't use it last time, so we use the others. So we use these ones to cover the front part of the brush tube. In this case, we're gonna use these ones. So we copy it, we paste it here, and we insert them. So we're gonna need 1, 2, 3, 4, and 5. Only 5. So we're gonna insert components. Okay, I think it didn't copy. Wait a second. Oh, sorry, not this one. We're going to introduce this later, but right now what we need. Yeah, use this one, the axial screws. So we copy it, we paste it here, and we need to introduce 5 of them. One, two, 3, 4, and 5. And again, let's add all the relationships. So this and this must be concentric. Remember to save your work just in case something goes wrong. Okay. So this and this must be coincident. Okay. And the same with the rest. So this part here and this part here must be coincident. Concentric, sorry. And this part here and this one coincident. Perfect. So we have everything in place. Now, what we have to do is introduce new spacers. We're going to introduce, remember, the spacers, we can modify them because we're going to 3D print them. If we were going to build it, the actual, this mechanism, we will 3D print this part. So we can choose the height of these spacers. So what we're going to do is we're going to copy it. I can find them. Okay. So we're going to change the name because we already have a spacer in the here, which is the one that we modified the previous one. So we are going to create another one from the template folder. And how many spacers we're going to need? So we're going to need 1, 2, 3, 4, 5, 6, and 7, right? So we're going to create 7 spacers. So this is the first one. And you will see why I am doing all this. So right now we're going to introduce these spacers with a fixed width, and then we're gonna modify this width so that it is the one that we want, because some of the spacers will be larger and some of them will be smaller. And to be faster, we just create them at the beginning, and then we're going to modify its dimensions. So I think I have everything. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm going to introduce all of them. So close it. Let's insert components. And we're going to insert all the spacers. Okay, 1, 2, 3, 4, 5, 6, and 7. And we're going to place them in the where we want. So for instance, the first one can go here. So mate, concentric with this place, perfect, and make it coincident with this, perfect, no collisions. So we can go with the second one. So this and this must be concentric, perfect, and then this face must be coincident. This face must also be coincident. Perfect. The same with these ones. Sorry. Do the same for all the other spacers. So we need another spacer here, right? And this is going to be coincident with this part. And coincident here. Only to left. Perfect. You can see now the mechanism should be completely defined. I'm going to save it. Should be completely defined and move. I cannot move it anymore. Well, because I can, because I forgot this. So, whoop. Delete everything. Let's start again. So this face and this face is to be coincident. Now everybody should be joined. Nothing should be floating, even if we move it. Let's cross fingers. Let's see. You can see that it works correctly. And if we try to pull everything, something out, nothing can be pulled out. So it can be moved, but nothing goes floating into the air as in the as was happening before, right? So that means that we are in the good place. So we save everything. Okay. So we have done. Okay, we're almost finished. Now we have to introduce the thing that I already put into the folder, which is the set screws, shaft collars, which is this part. And so let's introduce, we will need some of them. So we'll need 1, 2, 3, 4, and 5. So let's insert them. Yeah. So 1, 2, 3, 4, and 5. So they will be put into this place. So look for this example. For instance, let's put this example. We're gonna put it here, concentric, and we're gonna make it coincident. Here. Now, yeah. So you can see that now, if we put a brass tube here, it can, if we press here so that the brass tube cannot go out, then it cannot go either this way or that way, right? Because to go that way, it is prevented the movement by this part. And to go to the other side, it is prevented by this. Because the brass tube will be, I mean, the brass tube is connected to this, so this cannot go inside the bushing, so the brass tube cannot go that way. And the same for this, the other way around. Here, the brass tube is connected to this because this will be pressed into the brass tube, and this cannot go inside that bar, so the brass tube cannot go to the other side. So this is another way of fixing this brass tube that will go inside. We have not put them inside, but this will be the last thing that we're going to do almost. So introduce the rods, the brass tubes. So with everything said, let's go to put it the rest of them. So this doesn't, it will go here, this one. Because the brass tube from here will go from here to all the way to the other side, right? Okay. So the same for this one. And the last one. Okay. So another thing, save everything. Another thing that we have done. Now we can change the dimensions of the spacers because it is really important to check for collisions. You will see that now we have a problem because it's a really small problem. Because we have introduced here this part, and now when it rotates, you can see, when it rotates, you can see that it is colliding here, right? Or almost colliding. So we want to give a safe space in this part, because if not, it's really easy that this collides. So what we're going to do is we're going to increase the height of these spacers, both this and this one, because we want both legs to be in the same plane, right? So if we increase this distance, we may also want to increase this distance. And that way, both legs will be in the same plane, and we will avoid possible collisions of this with this, because they are so close that even if this bends a little, this will collide, and with this will give problems. So we will open this, and we can double the distance of this spacer, for instance. So we open it, and we can say, okay, so this extrusion was made this distance, right? So we can multiply it by 2, for instance, and that's it. Save it. Yes, I want to actualize. And now let's do the same. So both legs are in the same plane. Let's do the same for this one. Open it. And let's change this feature, multiplying it by 2. Perfect. Right? You can see that now there is no collision. Right? Yes. There is no collision. And that both legs are in the same plane. We also need to change the dimensions of these spacers, because these need to reach that point. So what we're going to do is we're going to measure the distance from here to here. From here to here. And the distance is this one here, so we will copy it. Now we will open this spacer, and we will change the extrusion distance by the distance that we have just copied. We save it, close it. And you can see that we have the spacer that we wanted. And in the last, in the other side, if both legs are in the same plane, this distance must be the same. So we open it, and we modify it to the distance that we want. Save it, close it, accept, save it again just in case. And you can see that now everything is in place. The mechanism is moving properly. Right? So we can go to the next item, which will be introducing the rods. So we will need different rods, right? So, well, you will need 3 different brush. How many? let's see how many different brush tubes we need. So we'll need one distance, another distance here, and another distance here, right? So we will need 1, 2, 3, 4, 5, 6 different tubes, and from of 3 different distance. So we already have 3 of them, so that's perfect. Let's gonna introduce them. So the first one, for instance, can be the one that we are gonna introduce it here, right? So let's measure the distance that we want. So measure this distance from here to here. This is the distance that we want for the first tube. Now let's open it. This I am going to recycle the ones that we had from the previous model, the one that we are modifying. So I'm going to change it, this distance, and now it's going to be this length. Perfect. And I can introduce it here. So components, it's going to insert the first one, which is the length that we just modified. And this has to be concentric to this. And this has to be concentric. Okay. Before we continue, I have to modify one thing also. So you can see that if we want these 2 legs to be, so you can see this spacer, that it's getting a little bit into this. So if we put evaluate and detect interferences and we calculate, you can see that there is a little bit part that this spacer, it's interfering with this wall, while in this case it's not happening. So if we do selections and we select this one and we calculate, in this case there is no interferences. So why is it happening? Why do we have this interference here? Because they are not completely in the same plane because of this bushing that we have here. So we need to introduce this distance here. So it's really easy. We just calculate the distance between this surface and this other surface, which turns out to be this distance. Copy it. Now let's open this one and change its a little bit its length. And right now there should not be interferences. You see that it was interesting to have different bushings. I mean, different spacers. Sorry, different spacers. It was really useful to name them differently, right? Because now if we change this is not being changed. So right now if we make interference detection, it shouldn't say anything. So yeah, no interferences. So we are good. Okay, let's go back to the brush rods. So we need 3 of the same length, which will be this length, sorry, only 2 of them. So we need this length and this length. So we need one brush rod that comes from here, from here to the other side. So this distance, this one, so copy it. Now let's open the second one. and modify its length. Save it, and let's introduce it into the SolidWorks model. We need two copies, one from here, one for this part and one for this joint. So assembly, insert, want to insert the second one for this, and we want to insert another one for this part. Okay, so this has to be concentric to this, and this has to be coincident with this part. Perfect. This has to be concentric with this part here. Perfect. And this has to be concentric with this part. Perfect. Now we need another one of distance. From here to here, from this distance. So we copy it, we open the third brush tube, and we modify its dimensions. And now insert it. You see, this brush tube will be fixed at this point by this, and at this point by the screw, so it won't be able to move, to go out. Okay, so we have a brush tube here, a brush tube here, a brush tube here, a brush tube here. We only need two more here of the same length. So we are going to create another one. We have run out of brush tubes, so we need to go to the templates, copy it, and paste it here. So, and it will be the fourth one. Okay, open it. And what's the distance that we need? We need a distance that goes from here, to here. Now, copy it. Let's go back to the tube and change its dimensions. Close it. And now insert it here. This has to be concentric. And this and this has to be coincident. And the same in the other side. So we need to insert another one. In order to save ones in a line. So made this concentric. And this coincident. Perfect. And we have brush tips now everywhere that we need them. And the mechanism works perfectly. Save it. Let's go here. And now we have to color the bars, because in this subject, in this course, we will pick the color green for the cranks, the color blue for the intermediate bars, and the color red for the output bars in a 4-bar mechanism. So we are going to select, for instance, we want this bar to be green, right? So we have selected this bar, and this is the bar that we want. We select another one, you will see that it will change. But no, we want this, which is the crank, to be green. So we have this selected, we go here, we right click here and say, sorry, we left click here and we select appearance. And we change the color. We said we wanted it green, so we select this color, for instance, and we press OK. We will do the same for this one, right? We want it green. What we can do is do the same, or we can also copy here, select here, say copy appearance. Now select this, don't know which one. Now paste appearance, perfect. Now this, I want it blue, so appearance, I want it blue. Okay. Okay, now copy this appearance, and I want to paste the appearance here. And finally, this must be red. We can copy the appearance and paste it here. Perfect. Now we don't need it anymore. And we have our mechanism in color. Now, if we go to motion study, it won't work because it is working with what we had previously. So we have to delete it. So we have to create new motion study and we have to delete it. By the way, we have completed this. We only need to check animation and do the video. So the animation was, we need to create another one. We will rename it as 1, because if there is not a 1, if there is not a 1, there is, doesn't mean, it makes no sense to have a 2. So let's add a motor here. Remember, the speed that we wanted was 20. We can increase or decrease it as we wanted, but we saw in the previous video that 20 is a good speed. We will make a 12 seconds video or more. And now we can also start from here. Then go to here, for instance, to the 4 seconds, to the 5. This moment, we want to change the orientation a little. Then we will want to approach a little. Maybe finish the other side. So that will be our mechanism, and now it's working properly. So with all the parts that we wanted. So thank you very much for watching the video. Remember to save everything when you finish. And remember that this is the button that lets you import the animation into a video file. So thank you very much again, and see you in the next video. Bye.